I'm Anil Kumar, and in this video we will try to understand how to sketch a polynomial function when it is given in factored form. Sketch the possible graph of f of x equals to x squared times x plus 2 times x minus 1 whole cube. You will notice that I have taken three different kind of zeros in this particular example, and that is to explain you how these zeros differ, right? So whenever you're trying to sketch a graph, what should you consider? Few things are very important. One of them is degree. You should always start with degree of the function. So you can get degree of this function as 3 plus 1, which is 4, plus 2 as 6. So we have degree of 4. It means the function has even degree, right? Then we have to see the leading coefficient, right? What is the leading coefficient of this function? Leading coefficient you will get by multiplying the coefficients of all the x's. In this case it is 1, right? So in this case it is, let me write plus 1, we say positive leading coefficient. Now these two things will tell you about end behavior. If the leading coefficient is positive, it means right side up. So that means right side up. Now these are my ways of sketching. You'll not find these rules in your book, but that is how I do it. If you like, you can copy this method. Degree 4 even means both same ends. So that means both same ends. So that is the end behavior, which is defined by degree and leading coefficient. Do you understand? First and foremost. Next, we have to look for zeros. Now, some books will say x-intercepts, but when we come to details, we look into zeros. X-intercepts are just the points where the graph crosses x-axis. Zeros indicate their behavior. How do they cross? And while sketching a graph, that is more important. So let's begin by writing our zeros. First zero, if you move from left to right, is at 0, right? So these are at x equals to, the first one is 0. And under the 0, I will write its order or multiplicity. How many of these? That is the question. How many at 0? 2 of them. So that is the order. The second one is at minus 2. So the next 0 is at minus 2. How many? We need not write 1. It is understood. But for clarity, I'm just writing. This 0 is at, when this factor is 0, right? X minus 1 is 0 for x equals to 1. So it is at 1. Okay. And the order is 3. There you go. So we got these 3 zeros. So it's time to mark these zeros on your x-axis. So one is at 0. Okay. The other one is at minus 2. So let us say this is minus 2 for us. Okay. And then we have one at 1. Okay, so in that case this is 1 for us. Well, I should have given more room in any case. Now once we know our zeros, then we should also find a y-intercept. So easy calculations, right? Now y-intercept is x equals to 0, and what is the value of y? So if I write x0, in this particular case, I get y-intercept also as 0, right? Which is the same point. Now, for a good graph, it is good to have values here also, in between these two values. That is to say, you may calculate the value for in between zeros, right? So from 0 to 1, it is 0.5, which you should calculate. And then between 0 to minus 2, the value of the function at minus 1, you should calculate, right? So I'm not calculating for the time being, right? But you will do the calculations and write those values. Okay, so what I will do is I will just sketch the graph with the information I've placed here, and you will fill in for the value so that the graph which you sketch is far more accurate than what I'm going to show you here, right? That's the whole idea. You should be doing a better job than me, right? Now, let us look into the zeros at a greater detail. What we have understood so far is that it is an even degree function with positive leading coefficient, 3 zeros, multiplicity of, if you move from left to right, 1 for minus 2, 2 for 0, and 3 for 1, or different kinds of zeros. So minus 2, 1 means what? Our graph, when we start from left to right, is approaching from positive infinity. It crosses x-axis at minus 2, and the 0 is linear. So like a line, it crosses like a line. This is what it means. So we are now here and approaching the next 0. We have to turn, but next 0 is order 2. Like a parabola, the graph bounces back like this. Do you see that? It bounces back and then tries to approach the next 0, which is like a cubic function. So the cubic function is kind of like this. Do you understand? So that is what you get. Now what we need to do is join these points. See how I'm joining these points? There you go, right? And here I'm just connecting them like this. Do you see? And then here, okay, there you go for infinity, right? And then you continue here, and then this. That is the parabola which represents the given equation, right? You will appreciate, well, if I would have taken this further away, I could have given you a good glimpse, but this is not bad, right? Okay, so that is the x-axis, and this is our function f of x. It's always a good idea to label it. But if you would have found these values, so minus 1 you calculate, right? This is minus 1. So this point will be f of minus 1. Do you understand? And minus 1 is my x. So you have to fill in so that you know what the y coordinate is, right? Accordingly, you can scale your y-axis. That's the whole idea. And at this point, you calculate that point so that you are in a position to write this point coordinates as f of 0.5, correct? Now when I put this, it becomes as accurate as yours. But I hope you understand the concept. Always do all these things. Show your values, right? At times you may have to describe it, the end behavior. So describe your end behavior. End behavior is when x approaches negative infinity, y approaches positive infinity. When x approaches positive infinity, y approaches positive infinity. Same ends. Do you understand? That is very, very important. I think with this you've understood all the concepts. You've understood how these different kind of zeros behave and how do we combine all these things to sketch a neat, smooth polynomial graph. Thank you and all the best.